Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the lines. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we are required to evaluate the orthographic projections of an oblique line AB in which the end A happens to lie in the first quadrant and end B of the line happens to lie in the third quadrant. So here let us first of all go through the problem statement. Point A of a line AB, it happens to lie 25 millimeter above the horizontal plane and 20 millimeter in front of the vertical plane. The front view of the line, it is inclined at an angle of 30 degree to the XY reference line and it measures 70 millimeter. Point B of the line AB lies in the quadrant number 3. Now another information available with us, it is the plan of the line is inclined at an angle of 45 degree with respect to the XY reference line. So with this information, we are required to draw or construct the orthographic projections of the line, that is front view, top view and the right hand side view projections of the line AB we are required to draw over here. Now let us proceed with the construction of the orthographic projections of the line AB. Now here we have drawn the XY reference line, X1, Y1 reference line, and since in this particular case we have got two ends of the line, they are lying in quadrant 1 and quadrant 3. So we are not going to use simple transfer line over here. So rather a long transfer line which will be protruding into two quadrants over here has to be drawn. This way a long transfer line at an inclination of 45 degree with respect to the XY reference line protruding into two quadrants we need to draw over here. Now let us proceed with the orthographic projection. So end A of the line AB, it happens to lie in the quadrant number 1. So end A, it is lying 25 millimeter above the horizontal plane and 20 millimeter in front of the vertical plane. So A dash point corresponding to the end A, that is front view projection of the end A, will be located at a distance of 25 millimeter above the XY reference line. Similarly, the top view projection of the end A, it will be lying 20 millimeter in front of the vertical plane. So it means that 20 millimeter below the XY reference line, we have to draw the top view corresponding to the end A over here. Now, having obtained points A dash in the front view corresponding to the elevation of the point A and point A, that is top view projection corresponding to the end A in the top view projections. Now we have to draw two locus lines emerging from points A dash and A over here. Now we also know that the front view of the line, it is inclined at an angle of 30 degree to the XY line. So usually you see we would have drawn this angle of 30 degree into this orientation had we got end B of the line located into the quadrant number 1. But since we know that end B of the line happens to lie in the third quadrant, so in the third quadrant we should be able to obtain front view projection of the end B below the XY reference line and the top view projection of the end B above the XY reference line. So only then we will be obtaining the coordinate locations of the end B, certain distance below the horizontal plane and another certain distance behind the vertical plane. So now we have to proceed with inclination of the front view projection of the line into this orientation, that is this 30 degree angle we have to draw in the downward direction over here. And the moment we mark this angle of 30 degree, now the front view projection of the line A dash B dash will be drawn in this orientation in such a way that the length of this projection A dash B dash should be equal to 70 millimeter, because this information is also available with us in the problem statement that the front view, it is inclined at an angle of 30 degree to the XY reference line and it measures 70 millimeter. So here from the point A dash we have drawn a locus line. So with respect to this locus line we have marked an angle of 30 degree in the downward direction, so that end B, it should be located in such a way that the front view projection B dash, it should be lying below the XY reference line over there. That is, now we will see that point B of the line, it is located certain distance. So this distance we can measure. So this distance we are going to mark as the distance Y over here. So this is the distance Y, which is the distance of the end B below the XY reference line, right? So once we obtain A dash, so using this 30 degree inclination of the front view projection measuring 70 millimeter, we have been able to obtain end B dash of this particular line. So the front view projections of this line, they have been obtained. Now once we have obtained the point B dash over here, so from this point B dash, so we need to draw a vertical projector over here. So this vertical projector line will mean that the top view projection corresponding to the end B, it will be lying onto this particular vertical projector line, and it must lie, that is the top view projection, that is B point, must lie above the XY reference line. Only then we will have end B of the line located into the quadrant number 3. So we are also provided with another information, that is the plan or the top view projection of the line, it is inclined at an angle of 45 degree with respect to the XY line. So otherwise, if this information was not available that the end B is lying in quadrant number 3, so we would have drawn this angle of 45 degree into this orientation. But here if we draw 45 degree projection in this orientation, then end B will not be lying in the third quadrant. So rather this end B will happen to lie in the fourth quadrant over here. So what we have to do now, this angle of 45 degree has to be drawn into this orientation. That is, we are going to mark angle of 45 degree in the upward direction, and then we know that once we draw this particular plan projection line over here, so we are going to draw this plan projection line and extend it till this extension meets the vertical projector line which is emerging from the point B dash. Why? Because B dash and B point, they will be lying in the same vertical projection line as per the projections of the point principles over here. So from point A, we have marked an angle of 45 degree, that is to define the orientation of the plan projection line. So having marked this orientation of the plan projection line, so we have drawn a projector line from point A. We are going to extend this plan projection line till this plan projection line, it intersects with the vertical projector which is emerging from the point B dash. So this intersection will provide us with the point B, that is the top view corresponding to the point B has also been obtained. So A dash has been obtained, B dash has been obtained, that is the front view projections, they have been obtained. Similarly, point A and point B have been obtained over here. Now this represents the top view projection corresponding to the line AB. So A dash B dash, it represents the apparent length projections of the line in the front view. AB projections, so they represent the apparent length top view projections of this line AB. So as we had discussed, we have to evaluate the right hand side view projections of this particular line. Now in order to evaluate right hand side view projections of this line, we know that the right hand side view projections should be drawn on the left hand side of the front view projection. So these are the front view projections. On the left hand side, we are going to obtain the right hand side view projections corresponding to the ends A and B of the line AB. So another fundamental, we know that whatever it is the height of the point A dash in the elevation, so at the same height we will be obtaining the location of the side view point over here. That is, the side view point will be located onto the horizontal construction or the projection line which is going to emerge from the point A dash in the elevation. So this height of the point A double dash has already been fixed as per the fundamentals of the projections of the line. Now we have to transfer this distance, that is the distance of the end A in the plan view. So this distance happens to be 20 millimeter. So this distance has to be transferred onto the profile plane projection. So now we know that end A, it is available with us at a distance of 20 millimeter in front of the vertical plane. Now through point A, we have to draw a projection line and extend this projection line till this projection line meets this transfer line which we had drawn at an angle of 45 degree. So once this projector line which defines the distance of the point A from the vertical plane, it intersects with the transfer line. So one point onto the transfer line corresponding to the point A of the plan has been obtained. And now from this point, what we have to do? We have to draw a vertical projector line and extend it in the upward direction till this vertical projector drawn through this point, it is going to intersect with the horizontal projection line which had been drawn earlier emerging through the point A dash over here. So wherever we obtain the intersection of these two projection lines, so we are going to obtain the location of the point A double dash over here. And the moment you see we obtain the location of A double dash, let us check out the coordinates of the point A double dash. So point A double dash lies 25 millimeter above the horizontal plane and 20 millimeter in front of the vertical plane. So this distance happens to be 20 millimeter in front of the vertical plane. So by using this transfer line, this distance from the top view, that is alongside the depth, has been transferred into the profile plane over here. So now this distance is 20 millimeter in front of the vertical plane, right, into the profile plane. So this way A double dash point has been located in the side view projections. Now let us proceed with the evaluation of point B double dash. So on the similar note, we also know that this distance of the point B from the XY reference line, so this happens to be distance Y. So it means that point B dash, it is going to lie Y millimeter. So we don't know this distance as of now. So whatever will be the distance of point B in the front view measured with respect to the horizontal plane, so we will see that we have assumed that this distance will be Y millimeter below the horizontal plane. Similarly, this is the point B. So how much is this distance over here? So this distance again we have measured as distance X over here. So we know that point B, it will be located X millimeter distance behind the vertical plane. So if this point B is located Y millimeter distance below the horizontal plane and X millimeter distance behind the vertical plane, only then this point B will be located in the third quadrant. Now we also know that whatever is the location of the point B dash in the front view projection, that is Y millimeter below the horizontal plane. So at the same location, our point B double dash will also be located into the side view or the profile view projection. So what we are going to do, we are going to extend the projection which is emerging from B dash over here. So we know that B double dash point, it will also be lying at a distance of Y millimeter below the horizontal plane into the profile plane projections over here. Now let us transfer this distance of x millimeter behind the vertical plane. So from point B, we are going to draw a horizontal locus line and extend this horizontal locus line emerging from the point B till this horizontal locus line corresponding to the point B, it intersects with this transfer line. So the moment this projection line, it intersects with the transfer line over here, so we have obtained a point corresponding to the point B onto this transfer line. And now from this particular point corresponding to the point B onto the transfer line, we have to draw a vertical projector line in the downward direction and keep on extending this projector line till this vertical projector line, it intersects with the horizontal construction line which we had drawn through the point B dash over here. So wherever the intersection of these two projector lines we are able to obtain, so we will be able to obtain the location of the point B double dash over here. Let us check the coordinates of the point B double dash into the profile plane projections over here. So point B double dash, it lies y millimeter distance below the horizontal plane, and we can check this distance is x and this distance is also x because the angle of the transfer line happens to be 45 degree. So it happens to lie x millimeter distance behind the vertical plane. So this distance is behind the vertical plane. This distance is below the horizontal plane. So this way, the location of the points A double dash and B double dash have been obtained into the profile plane construction over here. Now we can join A double dash point with B double dash point and we will be obtaining the right hand side view projections of the line AB, for which point end A, it was lying in the quadrant number 1, and end B of the line, it happened to lie in quadrant number 3. So this way, using the fundamentals of the orthographic projections of the line, we have been able to obtain the apparent length front view projections, the apparent length top view projections, as well as the profile plane projections, that is the right hand side view projections of the line AB, in which the two ends, they happen to lie in the different quadrants. So end A, it was lying in quadrant 1, while the end B of the line, it happened to lie in the third quadrant. So this is all for today. So I hope that through this discussion you would have understood about the procedure to evaluate the orthographic projections of the line when the two ends of the line, they happen to lie in the different quadrants. So we'll be continuing with further discussion regarding few more illustrative cases related to the projections of the line in the coming lectures. So thank you very much. Thanks a lot.